Hey everyone, welcome to the Onelink project pitch. My name is Professor Can Vuran, and we'll be talking about Onelink project. Let me start by talking a little bit about myself. I'm directing the Cyber Physical Networking Lab. We're working on wireless networks of systems that we're aware of, can timely adapt to and change their environment. And as you can see, we're looking at how these networks touch in every aspects of our lives. I'm fortunate enough to work with a lot of students and partners from all over the world. Our publications have so far received 20,000 citations. People seem to like our work, and our work has been listed consistently in Thomson Reuters highly cited researchers list, which lists the top 1% most cited researchers for computer science. And you can see at the bottom the places where our graduates work these days. So we are going through an exciting transformation when it comes to wireless networks. With 3G, we were able to connect our phones to the internet. With 4G, we have really been able to use the power and connectivity of smartphones. And with 5G nowadays, we're going one step further to look at all sorts of use cases and applications that require connectivity, be it higher bandwidths, smaller delays, or much larger densities of connectivity. So to be able to accommodate research in these areas, we have been partnering with the City of Lincoln and a large group of researchers from academia and the industry on developing our vision of Nebraska experimental testbed of things. Our goal is to design a one network platform that can support development of unique next generation applications. Some of these applications are listed here: real-time police vehicle camera video streaming, urban underground infrastructure monitoring, and real-time soil monitoring and irrigation automation are some of these applications. And we are working on developing advanced network architectures to enable these applications that have distinct operational requirements. So as a result of this, we designed and developed Next 1.0. It's a remotely accessible experimental wireless network that is built on 7 wireless sites so far. It's deployed on city infrastructure, UNL fiber, and rural agricultural fields. You see the 2 main locations where this testbed resides here, which is Lincoln, Nebraska, as well as agricultural fields in UNL's Eastern Nebraska Research, Education, and Outreach Center, NRAC at Mead. The network supports cloud-based baseband processing and also has multi-user access functionalities. When we look at the city, the testbed is deployed on several locations. These are both rooftops of UNL buildings, as well as a traffic intersection and an indoor location. And that this whole testbed is interconnected and can be remotely accessible, providing a very unique resource for us to perform our research, and it's also used within our classes. So you can see our aggregation switch here, the WestSec Fiber Hub, which interconnects these sites. These are some of the pictures from our sites. This is the old Father Hall rooftop deployments with antenna arrays and GPS and the radios. And this unique site is the small cell deployment in Antelope Valley and Vine intersection, which we developed in collaboration with the City of Lincoln. This is one of the few wireless experimental testbeds that is deployed on a public infrastructure with strong collaboration with City of Lincoln. We also have an indoor deployment, which allows us to prototype our solutions and perform operations. So for some of you, this may look like a very complicated network, may even scare you in terms of tackling a project like this. And this is the very core of this project, which is we want to make access to these complex networks very easy, which is the Onelink project. So what is Onelink? Let me give you an example. You want to be able to do this. Hey, Siri, run me a wireless experiment.
You'll need an app for me to help you with that. You could try searching the App Store.
As you can see, we cannot do this, but this is the goal. You'll be working on integrating web technologies that are highly successful, highly modularized, and can be integrated easily to be able to control this complex network. You won't be starting from scratch. This is our existing software architecture. You can see that we have been consistently integrating cloud-native solutions. We have containerized components that control some of the radios, VM-based control flow for some of these network architectures, and they are all integrated through a single link that we can access through a web page. Next, I'll show you a short video of a web access to the testbed and how we can now perform experiments of very complex radios. These are millimeter wave radios that are being integrated into the 5G networks. And we're basically using them just like you would with any web browser. So let's look at the video.
In the lab from anywhere remotely through the browser. User can freely customize the configuration of the hardware through the configuration section. Once the configuration is okay, user can go to the operation section to run the application. So the output of the DJ Sounder application will synchronize with this web UI, so user can monitor this process. So under this current setting, the experiment will take about 10 minutes. We will come back when the experiment is done. Now the experiment is finished. For quick evaluation, the web UI will visualize the result as heat maps. User can also download other raw results to their local machine for future analysis.
So this is what we can do right now. And for this project, we are looking forward to build on top of this existing architecture. What we'd like to see is tight integration with web technologies. We want to make the interaction with this testbed as convenient, as easy as possible. We're looking for native TensorFlow integration for machine learning, deep applications, so that we can support deep learning for wireless solutions. And on top of all, I'm also looking forward to working with a diverse and enthusiastic team of CS, SE, and CE students who might have experience in all sorts of aspects of this project. So this is our project pitch. I hope you join us. And if you have any questions, feel free to shoot me an email. I'll be glad to answer any questions you might have, and I look forward to working with you. Thank you.